Where do engineers and designers at companies like BMW, NASA, and Bosch get custom manufactured parts fast? Xometry. With Xometry, anyone with a 3D model can get pricing and order parts thanks to Xometry's instant quoting engine. Access dozens of manufacturing processes like CNC machining, sheet cutting and fabrication, 3D printing, injection molding, and more, along with hundreds of materials, all in a matter of seconds. Check out Xometry today at xometry.com. That's Xometry.com. Xometry, where big ideas are built.
It's not even about the accomplishment itself, but it's the ability to persevere, work together, and overcome the challenges that is so rewarding. There's no feeling like it.
Hello and welcome to another exciting episode of the Being an Engineer podcast. Today we're speaking with Derek McKenney, who is the Director of Engineering at Puritan Medical Products, where they manufacture medical swabs and related products. Derek is responsible for corporate and site-level engineering in multiple facilities, including manufacturing support, capacity expansion, process validation, continuous improvement, and project management. Derek, welcome to the show.
Oh, thank you, Aaron. It's my pleasure to be here and looking forward to a chat today.
Awesome. So am I. So what made you decide to become an engineer?
So for me, probably a little bit of the stereotypical engineering story. I mean, I was always really interested from a very young age in why things worked. And that sort of transitioned from more of a sciencey feel to much more mechanical things. So it was like my box fan stops working. I have to tear it apart and understand exactly what an electric motor is and, what this is all about. And it transitioned to, as I got older, the lawnmower, and then later in life it transitioned to process automation and, getting an engineering degree. But it's always been a seeking to understand the why, and all things mechanical that really led me there. And, for better or worse, I knew I wanted to be an engineer very early, probably by the time I was in middle school. So my sights were set on an engineering degree before they should have been. But, I've always known what I wanted to do. That's something anyone that knows me will tell you.
Yeah, it's terrific. I love that you mentioned taking things apart and figuring out how they work. It reminds me of when I was, 8 years old or something. I had this FM radio. It was like a portable battery-powered FM radio with a little jack for headphones. And, you plug the headphones in and you can hear the audio. For some reason, I took the back cover off and I was just playing around with the headphone jack. And I happened to find just the right contacts internally. I don't even know why it did this or if it should have done this, but just the right contacts for touching the metal of that headphone jack connector would produce the same audio as plugging it into the receptacle it was supposed to go in. And I was so excited that I had quote unquote figured this out, right? But anyway, same thing for me. I loved taking things apart and just looking at the internals and figuring out how they worked.
It's the knack, as Dilbert calls it, right?
I think there's like an audio clip about that. Your son is going to become an engineer. Oh no, the knack. He has the knack.
Exactly. Yeah.
Well, you are you're a director of engineering. You're in a leadership position, and I guess what are a few of the things, like the most influential factors that you think allowed you to climb to that level?
So I think the first really was, my commitment to bring people together. I really strive to drive collaboration, which is something in engineering. It's very easy to become siloed, very easy to have individual contributors that are sitting together but not necessarily working together. And, I've always prided myself really to focus on making sure everyone around the table is working together. That's probably the biggest contributing factor. Management and leadership are a little bit different. So being able to lead people That's something that I've sort of fallen into in just managing projects and again, bringing people together and, and realizing that, I could do more than, I can do only so much as just an engineer, right? But being able to bring people together to build a team is so much more impactful and so much more rewarding for me as well. Taking a small group of motivated people and really going out and being able to make meaningful change, that really drove my passion around leadership and management and pushed, I pushed myself in that direction and continued again to build those relationships and those teams very early in my career, just at a cross-functional level, but always collaborating and, maybe going a little far outside my swim lane once in a while, but you have to find that zone.
Yeah, you got to stretch yourself sometimes, right?
Absolutely. And I think the second piece of that journey was always being somewhat aware of the bigger picture and thinking about things a little bit beyond myself and understanding not only, some synthesis, not only what my piece is, but, collectively, again, as a whole, being able to see a bigger picture and then really focusing on that makes it easier to jump into a different level in the organization and start to participate. And the third piece of it is really being in an organization that supports that organic growth, wants to bring people up internally. And that's something that Puritan I was lucky enough to be exposed to sort of midway through in my early career to really have some great mentorship and some good direction. I mean, that's really key as well. I mean, it's very hard to be a good first-time manager if your first-time manager that you have, by some standards, may not be the best. So those early habits that are built in relationships, those are very impactful. And I was lucky enough to have very good mentorship early in my career and still do today.
That's great. I love that you brought it back to people initially. I mean, everything that we do is through people. So one's ability to work with people, to get along with people, to coordinate with people is really such a huge driver. Of course, you have to have the technical experience and aptitudes as well, but without that people side, you're just never going to be an effective leader.
Yeah, and I think leading engineers is a little bit different than maybe other management roles, and mainly because you have the very specialized technical skill sets. So you have by default, subject matter experts, and the cross-functional work isn't again necessarily happening organically the way that it needs to in order to have ultimate success. So I think being able to see that, sort of judge some personality traits, and again facilitate that interaction is key to moving up to the next step.
Yeah, definitely. So speaking of moving to the next step, this might sound like an odd question, but I'm curious to hear, have you ever felt this imposter syndrome, right? Like, oh, why am I good enough to be here? I shouldn't be in this position. It should be someone else. Has that ever been a thing for you? Or have you always just been super confident? Yep, I got this. I'm right where I'm supposed to be.
Oh, not at all. I've especially even starting in undergrad, the feeling of, you go through all the effort with an engineering degree, and then you get to this point where it's like, did I really do this? Did I really learn? Am I really an engineer, or somehow did I just appear here? And the same thing early in my career, going to a large corporation at Becton Dickinson and getting thrust into large projects and doing well. Everyone telling me I'm doing well. I'm getting more responsibility, being promoted, and still thinking, how? Come on, when's someone going to find me out? And I think that for me, there's a few things to overcome that, and one of them is taking a step back and just looking at, hey, this was 5 years ago, and now this is today, and just visualizing how much I've actually grown. Letting go of some of that perfectionism, and I have this thing where I always say I try. I try, and that doesn't mean and I've tried to push that down, and I use the word try maybe too much, but it's an effort to not think about trying, but that I've actually legitimately done a good job, and that isn't something, that it's taken me some effort to put into that to get to a point where I can look back and say, hey, that was a good job. We did a good job as a team. I did my job. And instead of being critical and a perfectionist and thinking that, I'm about to be found out by someone for, not having not having done what it appears I have.
That's a funny phrase. I'm going to be found out. I feel like I have the same, and it's so funny. Sometimes I'll be talking with my wife and she'll say, "Oh, you did." I'll tell her about something that happened at work, and she'll say, "Oh, congratulations. That's great." And I'll be like, "Yeah, but this thing could happen, or I'm not good enough in this area." Just for some reason, this human nature just always comes back to I'm not good enough, or I shouldn't be here.
Yeah, it's a tough thing to overcome. I mean, it's not something that happens naturally, and it can become taking the focus off what you have done and focusing on what hasn't been done. Also, there's no reward in actually accomplishing something. So that's it definitely, after being in an engineering school, will put you in that position. I think most of my colleagues agree. You come out wondering how did I get here, because I don't think I did that right if I'm here now. But it's no, very true.
I attended this coaching workshop where they talked about this idea of the gap and the gain, they called it. And they made an analogy between the horizon being your ideal, where you think you should be, where you want to be, and the fact that you can never get there, because the further you move, the further the horizon moves, right? You're on a boat sailing and you're never going to get to the horizon. You're never going to get to that ideal where you think you should be, where you think you want to be. So it's really important. And you said exactly this. It's much more important not to look at the distance between where you are and where you want to be, but looking back at the gain, they call it, right? There's the gap between where you are and the horizon, and the gain, what you've actually gained over the past, whatever it is, year, 5 years, 10 years.
Absolutely. And that's something that, I mean, it takes, again, it just takes effort. It takes a little therapy. It takes all those things to really overcome.
Yeah. Yeah. Well, what trends are you seeing these days in medical device manufacturing? I mean, maybe it could be something about the costs involved, or new processes being used, old processes that aren't being used, materials, just kind of what patterns are you seeing in medical device manufacturing?
Yeah, so for us specifically, right, we're in sort of a single-use disposable business, and we're also a somewhat highly customized manufacturer. So we do a lot of work that is sort of mid-range volume to lower volume, very custom SKUs. And again, every large company that has a diagnostic test needs a specimen collection device. And oftentimes, the device is designed specifically for that test. So one challenge that we've had to overcome, is how to be flexible with our automation, how we can integrate a lot of what has been developed for other industries around flexible automation platforms. Again, in the medical device world, it takes us a little bit to adapt to new technologies for a lot of different reasons. But change, needs to be validated and vetted very thoroughly through, existing risk management procedures and quality management systems in place, both in the United States under the FDA and globally under different regulations. So for us to move towards new technologies, it takes a little bit of time. So we tend to be watching what other industries are doing, and then we catch up a little bit as the technology proves out. But again, that's a big move for us, is really towards, how can our automation platforms become more flexible? How can we address different product lines and still maintain efficiencies? Because medical devices are, to some extent, a commodity, especially in single-use environments. So we have to remain cost competitive and still deliver exceptional quality. I mean, there is a patient on the end of everything that we produce, and it's at the utmost importance to never lose sight of that. I mean, that's one reason why I don't think I would ever work in another industry besides medical device, because there's so much at stake for global health, and it's someone's relative, grandmother, brother on the other end, and it's that level of connection just doesn't come if you're making a roller chain, or at least for me, or maybe a consumable on the consumer side. So it's really meaningful work, and that drives innovation around the patient. And in our case, trend-wise, we're really moving towards patient-centered care. So in-home, at-home testing. So instead of having, again, maybe a large device that needs a provider to use with some special use instructions, moving to something that has been designed to be used at home by someone that can read a short IFU and perform the test. And COVID really accelerated this. At-home testing was something that, we didn't see a lot of until COVID. Now we have all of these rapid tests all over your local pharmacy, being distributed by the U.S. government. And that has opened up a door, now for approvals around flu testing or combined flu and COVID. So that means shrinking these test kits, getting them to go on shelf space. So making things smaller, more compact, more efficient. And that's really driving not only the technology for manufacturing, but also the product design itself, because we're moving away again from something we assume a trained provider may administer to something that's really designed for at-home use, which even for a nasal sample, it's not intuitive to just insert the swab, let's say, an inch to an inch and a quarter in your nose. You may, with a provider, they know to do that. And historically, there was some resistance to how do we prevent somebody from, inserting this beyond a safe depth? Do we need a hard stop engineered into the device? Do we need a specialized sampling device that maybe isn't a traditional nasal swab as we know it? And, we're starting now to see, as we see that trend move, we're able to understand sort of the clinical impact of some of these devices, and that maybe some of that risk was a little bit, we might have overstated it a little bit with COVID, right? We were able to go out into the market with an at-home test that was effective. And now that's kind of now the prior art and the baseline for what will be really the future, I think, of diagnostic testing is home-based. I want the result on my phone. I want it to Bluetooth to the analyzer that's on my nightstand, and not have to worry about making an appointment or going to see a physician.
Now, if we could just get dentistry to be an at-home procedure, we'll be all set.
Yeah, I always wanted the full mouth toothbrush, and then I realized that was on the market. So it's been done now. So at least let's just plug it in and wait. It's just a little easier.
Well, baby steps, right? We're getting
exactly one step at a time.
Yeah. All right. Well, let me take a short break here and share with the listeners that our company, Pipeline Design and Engineering, develops new and innovative manufacturing processes for complex products, then implements them into manual fixtures or fully automated machines to dramatically reduce production costs and improve production yields for OEMs. We're talking with Derek McKenney today. Derek, what are a few of your biggest challenges as an engineering leader?
So one, I would say right now my biggest challenge actually comes from sourcing engineering talent where I am here in the state of Maine. And it's improving, and we're working on, outreach with local organizations and universities. But we've grown, and our needs have changed rapidly as a result of the growth we experienced during COVID, now sustained by non-seasonal business. But we're not in an area where there's a lot of manufacturing, right? Maine isn't known as sort of a hub of manufacturing or technology, although we do have here in southern Maine kind of a unique little biotech community starting with some new startups and new companies. So the state of Maine is really taking the time and effort and putting some funding behind building and attracting not only educational institutions. Northeastern just opened the Rue Institute here in Portland, so we're seeing some additional attention from outside the state, which is very helpful, as well as some new innovation here in the medical device front, which is great to see. It's great for the state, and it is helping. But again, to find that talent, experienced engineering talent, it is a challenge, and it does take time. We've done well so far, but it definitely it doesn't come easy. And I would say the second challenge that we face here on a somewhat regular basis is our ability to, as an engineering team, and then that falls on me as well, to react to the never, it's not that it's a never ending, but there's always more and more customization requests. And as regulations increase, the effort required for product design and development increases as well. So being able to match industry standards and changing requirements with the staff on board is also an ongoing challenge, to make sure that we have the right expertise to support the products. And these are global products, so we have regulations spanning well beyond the borders of the U.S. Again, to make sure that we have the right skill sets both in the product development and the manufacturing front to align. Again, we're ever-changing regulations, so it's a constant effort to maintain that alignment.
How about, and there might be some overlap with these answers, but how about, what are the biggest challenges that you see facing the medical device industry these days?
Yeah, I would say it's the regulation changes, and I can maybe speak a little more in detail on that. In the U.S., we're a single-use device. We're a Class 1, considered very low risk. And we're exempt from some of the requirements of higher class devices. Obviously, we're not making implantables. We're not making pacemakers. We're making a specimen collection device. And different risks means different requirements. Now, as we expand globally, the requirements around Class 1 devices have increased. The devices haven't necessarily been upclassed, but the expectation is you have much more detailed documentation behind not only the design, but the manufacturing processes themselves from what has been historically required. So that means now a lot of legacy products, there's a lot of work to do. Products that have been on the market for 10 or 20 years, it's a substantial catch-up effort. And the dates for compliance, are somewhat set now. So, we've been working over the last year to bring our products into compliance. And, we want to maintain being a global company, but the cost of that has increased. So again, the challenge is not only, regulation, but the cost of compliance, and, they're woven together, but that's hidden a little bit in overhead, but it's something new. And in order to remain competitive, we have to look to our manufacturing operation to make that difference up in most cases. So it's that's where it becomes a challenge globally. We have to be very efficient manufacturers. We also have to meet all applicable requirements to stay competitive. So it's a balance there.
Speaking of becoming more efficient, what's a tool that if your team had, would make your engineering efforts, 10 times more effective than they are right now? And feel free to stray beyond the boundaries of known physics. It could be whatever, but what tool would make you guys just 10x more effective?
One thing that would definitely, if we had a, sort of a documentation button where we could just push the button and we could generate, our design history file, right? Just the sheer amount of time we spend creating documentation it can't be understated. It's something that gets lost, right? You do the work, but the level in which we have to maintain our documentation, it just takes so much time. If we could just, push that button and have that work documented, it would really, it would open up many, many more opportunities. But there's, on the risk management front, it's just, there's no way around it but time. And it's something that we spend a lot of time and resource on. And then, it's a requirement to make a quality product without question, but it consumes resources.
I hear you loud and clear. We are not a medical device company per se, although we work with quite a few, but we do a lot of documentation, right? The output of engineering is documentation. And it always shocks me just how long it takes even to do our, non-FDA compliant documentation, just drawings for manufacturing and user manuals and things like that. It always takes longer than we expect. And the other thing is most of the engineers don't really enjoy doing that work, right?
Yeah.
So it's like it's this thing that takes forever and nobody wants to do it.
And no one wants to write SOPs all week,
Yeah,
right? But it has
right.
to be done.
Yeah. Yeah. Let's see. If you had no limitations on time, resources, money, what is the one thing that you do for your company that you think would have the most significant impact on achieving its business goals?
So on a business goal front, take away the budgetary requirements. I think we could really, we've in a little bit about our history. We're a 100-year-old family-owned business. So we've, Puritan Medical Products has been around since 1919, and we've morphed and changed and evolved over the years. But to really get us to the next level, budgetary constraints removed, it's really diving into the automation piece of the business, and also, being able to build out a much larger team to support that transition. Again, we have a lot of customized products, and that takes a lot of customization, and being able to integrate that more into flexible automation platforms that can address those needs would have a significant impact on not only our ability, to meet customer needs, but also the performance of the business, and accelerating that, with paramount.
That's really interesting, and I think there's a ton of truth in what you're saying. We're also in the automation space, and that's something we hear from our customers all the time is we need to implement automation, but it's so expensive to implement automation. Like, how do you make it more flexible so that you can not only use it for this one purpose, but it can be repurposed? You want to expand the line, or you want to pivot the line into something a little bit different. How do you make the automation such that it can accommodate all of these different requests?
It's the fine line of trying to be a custom manufacturer and a high volume manufacturer, right? It's only so far you can go in one direction, but it's
Right.
It's a space that requires an extensive budget.
Yeah. Well, how do you see the future of medical devices changing in the U.S. over the next 5 years or so?
On our front, I really, as I kind of touched on a little bit earlier, I see it moving to the at-home testing, which means making more compact devices. This year, for the first time, we really saw a large market presence in the 3-inch, a 3-inch collection device, where the standard has been historically for many, many years, a 6-inch collection device. And a lot of that has to do with, moving to a retail shelf, right, where, space is a premium. So everything is, moving towards a little bit smaller footprint, but also being tailored to very, very efficient collection and release properties. So we're seeing more push towards flock-tipped applicators, as opposed to traditional spun fiber, which is the historical Q-tip. So that, and we have, several patented technologies out there for specimen collection that do this very well. And I think as the market moves that way, again, it's really about having something that's very effective at collection and release, and is also very compact. The days of having a large kit at the doctor's office are probably coming to an end soon. So it's It's that retail space that will be driving it.
Yeah. All right. What are some of the traits or habits or behaviors that you've seen in the most successful engineers, and if it's a different answer, also in the most successful engineering teams?
So for the engineer specific section, I think one thing is the ability, and it isn't something that at least I learned in school or that I've had a lot of engineers that have come through have, is the ability to identify the problem to solve. And, you're presented throughout undergrad with all of these problems, which you can solve and get a solution for, and that's fine. But once you're thrust into an engineering position, the problem itself may not be apparent. I mean, the ask may be there's substantial analysis between that ask and an actual problem. So having the structured problem solving skills to break down an ask like, hey, increase efficiency 10% or decrease waste 5%, to be able to take that, and that is a stretch, for sure, ask of a young engineer, but to take that and then actually be able to break it down into something actionable and then identify value out of those different problems that are identified, that's something that I don't think gets very much emphasis. Being in a manufacturing world, I don't see a lot of younger engineers that are coming right out of school with, let's say a Six Sigma class or maybe some lean training where it's a little bit different thought process. It's not so much about the solution as it is what is the problem I'm trying to solve. And that's often, that's a gap that takes some time and experience. That's another piece of, in the manufacturing world, that's the key is really digging in and getting some of that structured problem solving experience. And it's something that I haven't seen out of the gate. I think it's just a lot of which the curriculums are structured around, again, very specific subjects and first principles, which are necessary, but again, they have to be applied effectively.
Yeah.
And for an engineering team, I would say that the big thing that I see right now with my team, and that we have to work with, is making sure that we're properly leveraging everyone's strengths. And it's very easy to, again, when you have a team and everyone is leveraging their strengths, it's very efficient. And not to say that, there isn't time for growth and development, but that has to be managed, and making sure that, development of team members is managed as part of the project. Is an area where, again, with a lot of our expansion efforts, we had a small group of people moving very quickly with very little time. It was very important that we spent time learning only what was absolutely critical to learn. And I think that really goes back to having a team where the strengths and the weaknesses are known and everyone is transparent about it. So you really need transparency in the team to get to that point, and you need a team that trusts each other. And there can't be any boundaries, right? It has to be very cohesive. And I think, that comes in time, but it starts with trust, and it starts with good communication and, some conflict, so that we know that those, if we all leave a little bit disgruntled, then I think we know that we got to the place we needed to be. And again, all part of building a good team. But I think that together, again, identifying strengths and weaknesses through that process is definitely, that doesn't happen. It can be hard, regardless of technical skills. It can be hard to move.
Yeah. Well, just one more question, and then we'll wrap things up here. Specifically within the context of your role as an engineer, what is one thing that frustrates you, and conversely, one thing that brings you joy?
So one of the most frustrating things for me as an engineer is is kind of the open-ended solution. And I think it's the black and white nature of engineering, but getting to a point where the project concludes, but the engineering work, there in it, it's some of that gap, right? But it's where it's acceptable, right? It's acceptable, but it wasn't where maybe I, as the engineer, wanted to take it. Just didn't get to that next level. That just feeling of, just a little more time, and it would have been that much better. And I think that that's always frustrating, especially with improvement projects, is that, and maybe it's a little bit in the nature of improvement. I mean, there's always the next project, but it does get frustrating. But what really brings me the most joy is when and it goes back to the team environment. So, I mean, I'm all about the people, but it's being able to be part of a group of talented people who are committed, and being able to, on kind of the opposite side of that coin, achieve an accomplishment as a team, right? Overcome the challenges, right? That's it. It's not even about the accomplishment itself, but it's the ability to persevere, work together, and overcome the challenges that is so rewarding. To see that come together and to be part of something, there's no feeling like it. It's something that I think in a group-based engineering team, you can't. For me, there's nothing better. There's nothing better. So it's always fun, and it's always a blast to be solving problems. It's what I love about engineering.
I couldn't agree with you more. Doing hard things with people you care about, that is one of the greatest sources of joy in life, in my opinion.
Absolutely. Absolutely.
Well, Derek, thank you so much for joining me today and sharing all of your insight and experience with the listeners here at the podcast. How can people get in touch with you?
So I'm on LinkedIn. You can feel free to look me up, Derek McKenney, Puritan Medical Products, and we'll connect and we'll chat.
Awesome. Thank you so much again, Derek.
Awesome. Thank you. It's my pleasure.
I'm Aaron Monker, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.